Friends, how are you? In our today's class, we will discuss about the theories which are related with the acid and base. There are three theories in our syllabus. One is Arrhenius theory, second is brosted Lowry theory, and third one is Lewis theory. Out of three, hope two we will discuss in today's class. Okay, so I am starting first theory, which is Arrhenius theory. It was given in 1887. It was a simple theory which is based on the proton, that means H plus, and hydroxyl ion, that is OH negative ion. According to this theory, those substances which give proton, that is hydrogen ion or H plus, in aqueous solution, in aqueous solution means that when it dissolved in water. Okay, so those substances which give proton or hydrogen ion in aqueous solution are called acids, while those substances which give hydroxyl ion, which gives hydroxyl ions, that is OH negative ions, are called bases. So simply, proton donor in aqueous solution are called acids, while hydroxyl ion donor, OH negative ions donor, called bases. Okay, here are some examples of that. First one is HCl, AQ, AQ here denoting aqueous. Okay, AQ is denoting aqueous. Clear? So the first example is HCl. When HCl is dissolved in water, it releases H plus ion and Cl negative ion. So it giving H plus, so that is acid. HNO3 nitric acid, it also give H plus ion. H2SO4, it gives 2H plus ion. CH3COH, that means acetic acid, it give H plus ion. H2CO3, that is carbonic acid, also give 2H plus ion. Okay, so all of these give H plus ion, so they comes in the category of acid. Similarly, if we consider the base, then if you take the example of NaOH, then it dissolve and decompose into Na plus and OH negative. OH negative, that means it is a base. KOH, it also give OH negative. CeOH twice, that is calcium hydroxide, it also give OH negative. NH4OH, it also give OH negative. So because of the giving hydroxyl ion, they comes in the category of bases. Okay, so H plus donor acids, OH negative hydroxyl ion donor, that are bases. Clear? Here one thing for you which is very important for exam. Arrhenius theory said that the H plus ion of acid, H plus ion of acid react with the water, because H plus ion, that is proton, is a highly reactive chemical species. So it react with the water and make a stable ion, which is H3O positive, H3O positive, and it is called hydronium ion. It is called hydronium ion. This H3O positive is very important for our exam. If I am correct, approximately two times the formula of hydronium ion were asked in different papers. Okay, so that is a question important for you. So I am repeating again, the H plus ion of acids react with the water and make H3O positive, which is known as hydronium ion. Okay, now Arrhenius theory explain about acid-base neutralization reaction. According to Arrhenius theory, during neutralization reaction, the H plus ion, that is proton of acid, combine with the OH negative ion, that is hydroxyl ion of base, and give water. So according to Arrhenius theory, the neutralization reaction is H plus and OH negative ion. There is a question of 11th standard I want to discuss with you. The question is, what is the main product of neutralization reaction? If your answer is salt, then it is wrong. The main product of neutralization reaction is water. Okay, because formation of H2O neutralize the acid and base. Okay, so formation of water, because the neutralization, the name of reaction is neutralization reaction, and any chemical is neutralized when there is completely using of the H plus and OH negative ions. That's why it is the main product of neutralization reaction. Now let me move to this theory. There is a point of this theory, that is strong acid and weak acid base. Strong acid base, weak acid base. That means simply we can say strong and weak acid base concept. According to Arrhenius, let me discuss generally. Firstly, generally, then we will move on our topic. Strong, it word is used when acid or base completely ionized and give more H plus or OH negative ions. Because strong acid, that means more acidic nature or more basic nature if it's strong base, and more acidic nature or more basic nature is only possible when it produce more H plus or OH negative ions. So strong acid, that means the substance, acid or base, then the substance which give more H plus or more OH negative, and more OH plus or more OH negative is only possible when it decompose completely, ionized completely. Okay, so strong, that means ionized completely and give more H plus or more OH negative, while weak means ionized, do not ionize completely, or less ionized, or remain unionized. We can use three terms: less ionized, unionized, or less decomposed, and give less H plus or less OH negative. Clear? Now come to the topic. Strong acid are those acids which ionize completely, that means decompose completely, and give more H plus ions in aqueous solution are called strong acids. The inorganic acids like the HCl, HNO3, H2SO4, HCl means hydrochloric acid, HNO3 means nitric acid, H2SO4 that means sulfuric acids, comes in the category of strong acids. While weak acids are those acids which do not completely ionize in aqueous solution and give less H plus ion, are known as weak acids like H2CO3, HCOH, CH3COH. All of these three are organic acids. Similarly, strong base, those bases which gets completely ionized and give more OH negative ions in aqueous solution are called strong bases. Sorry, are called strong bases like NaOH, KOH, etc. Similarly, weak bases, those chemicals which do not ionize completely and give, sorry, if I didn't discuss with the example, that is NaOH, KOH of strong base. Now weak base, those bases which do not ionize completely and give less OH negative ions in aqueous solution are called weak bases. Like example, NH4OH, MgOH twice, etc., etc. Now limitation. There is two limitation of this theory. First, this theory could not explain the nature of those acids and bases which do not have H plus ion and OH negative ions. Like CO2 is acid, but here there is no H plus ion, so how it is acid? It could not explain by this theory. Similarly, BF3, that is a base, but it do not have any OH negative ion, so then why it is base? Such acids and bases do not explain by this theory. Okay. Second, this theory could not explain acidic or basic nature in non-aqueous solution. That means in the absence of water, how the acid shows their acidic and how the base shows their basic nature, it could not explain by this theory. Okay, so these are two limitations of this theory. Now let me move to the second theory, that is Bronsted-Lowry theory, concept of acid and base. It is a simple theory. According to this theory, acids are proton donor. That means those substances which give H plus ion are known as acids, and those substances which accept accept or receive proton are known as bases. That means proton donor are acids and proton acceptors are bases. For example, here Ha plus B. After the reaction, Ha convert into A negative. That means it releases H plus ion, so it is working as acid. After the reaction, B convert into Hb plus, so it receiving H plus ion, so it act as base. Okay, so H plus donor, that is acid, H plus proton acceptor, that is base. Now there is a one typical point of this theory, that is conjugate acid base concept. According to this theory, when an acid release H plus ion, then its remaining part act as proton acceptor, because it is donated proton, so remaining part has tendency to receive the proton. That means proton acceptor, and you know that proton acceptors are bases, so that means we can say the remaining part act as base. While or similarly, when a base accept H plus ion, then formed chemical species, then formed chemical species have tendency to donate H plus ion. That means it start to work as proton donor, that means as a acid. So acid, after donating H plus ion, the remaining part work as base. In base, when it receive H plus ion, then formed chemical species act as acid. That acid and formed base or formed acid are known as conjugate acid base. Are called conjugate acid base. There are two examples for you. One is H2O plus NH3. Here, after the reaction, you are noticing that H2O converting in OH negative ion. That means it donating proton, it donating proton, while NH3 converting into NH4. That means it receiving proton. Since it is donating, so it is acid, and it is receiving, so it is base. After donating H plus ion, the remaining OH negative have tendency to receive H plus ion, to receive H plus ion, so it start to act as base. So this acid and that base are conjugates. Similarly, it receiving H plus, so it is base. Now NH4 have as tendency to donate H plus ion, so it is acting as acid. So this base and this acid are also conjugates. Similarly here, HCl converting into Cl negative, that means donating H plus, so it is acid. Here it is receiving H plus, so it is base. So that acid and that is base. After that, Cl negative had tendency to receive electron, to receive to H plus, so it is working as base and it is acid. So these are also conjugate acid and base. Now the limitation, it has one limitation, that it do not explain about the aprotonic acid like CO2, SO2 or bases like BF3. That means those chemicals which do not donate H plus ion, or those chemicals which do not receive uh, H plus ions, how they are acid and base, it could not explain by this theory. Okay, so hope you like it. Thank you.